I've been having a lot of fun thinking about this for the last few days. Consciousness. And how do you explain how a bunch of neurons, cells like spaghetti, in your skull give you the experience of a colorful, textured world full of shaped objects? How do you how do you get this? How do you have this experience? They call it qualia. How do you? What is the experience of red? And say red is a qualia. So what is the experience of red, or any number of other things? I suppose they're qualia for hearing. I suppose smell. Anyway, so here's how it works. According to Uncle Norm, when I look at a scene, the light from the scene goes into my eye and activates, stimulates the receptors in the back of my eyes. And these send data to the brain. Okay. What the brain sees is not, say I'm looking at a tree, it doesn't see a tree. It sees a bunch, well, it doesn't see one. But what happens is all the neurons that are firing as I'm looking at the tree, at the scene or whatever, those firings, that information, those nerve impulses going into the brain, that is the brain's experience of the tree. It doesn't have a picture. Although, how we know it's a tree is that the neurons in the visual cortex are connected to the frontal cortex, and there's all sorts of it's way more complicated than I'm presenting. But I'm trying to give you, like, in principle, how it works, and you can apply it on a broader scale. So there's no pictures in your head. There's just neurons firing. So how memory works, I think, is, say we isolate a millisecond of the data that's coming into the brain, of the neurons that are firing in that millisecond. And I have an illustration. It's like all these different colors of neurons are sending information to the brain, and each different color has a different kind of information. Maybe a different color, maybe each one has a color information from a different part of the retina. So this is what happens in the brain. So there's long controversy about, years ago people used to think, well, the eye's like a camera, it takes a picture of the world, and then that was way too simple. So but what you can say that is true to what we understand of the brain is that the information that the eyes gets translated into neural impulses, and that's what your experience is. So, how qualia work is um, there is a pattern in the brain for, oh God. So the image that you see, that you have the experience of, the green that you see or the blue that you see, those are the neurons that have been activated by those colors, and the pattern of that combination of interactions is what the brain sees. That's its that's its information about the scene. So when you remember something, or somebody says, "Hey, what, do you remember that time?" Your brain just activates the same networks, the same pattern of networks that were active at the time when you saw the scene. So it's not as vivid as the scene itself, because you're not getting the additional information from the eyes. You're only getting, I guess, a watered down version. But the same neurons are activated, or the same pattern of neurons is activated when you remember the tree as when you originally saw it. So the memory is just the same pattern that the original image was. And what we call the qualia, say red. Red is common, right? So when red light in the wavelength for red hits the retina, it activates certain neurons in the brain and the visual cortex, right? So the activation of those neurons and all the connections they make with everything else in the brain, because the whatever red you're looking at will have associations with other reds you've seen in the past, and it'll have associations with different objects, different shapes that had that color of red. So when red impinges on the retina, all this cascade of things happens, and those constitute the experience of red. Just those neural firings. That is what your brain experienced when you originally saw the red, and that's what you experienced when you imagine the red. It's all just the same pattern of firing neurons. I hope that's clear. I mean, it's here's the way I started out was that the current understanding of how the brain works is that neurons interact with each other like networks. And so the question is, how would these cells lighting up or not, or if you want to call them firing, sending a signal to another neuron. I'm being kind of casual here. Fire, when they fire, okay? Okay, the question was, what was the question? Okay, I got the idea of what a visual image is. And really, if you're in the real world, that visual image will include sounds and maybe smells or something else. All those will be in that pattern for that particular image. So, whether or not you remember that depends on all those connections with other neurons, the associations that that pattern of firing has with other situations in the past. Was it a dangerous situation? Does that pattern of neurons firing, does that match a pattern that occurred before in which there was danger? Say, if that's the case, see, so the pattern you're currently experiencing, your brain's trying to figure, what do I do with this? And the way it does is it just compares it to previous occasions when this pattern existed. There's not a function, a compare function, you know. It's just that the current pattern that exists connects or activates every other pattern that's similar to it. So it's just a matter of it's not a matter of some brain function selecting things. They just connect, they match with other neurons or they don't, you know, and all those associations go into the perception of any one thing, you know. Everything that we've ever experienced in connection with it in the past gets activated when that pattern shows up in the brain. It's amazing. You know, it's amazing, but like there's something like 84 billion neurons, and the number of different ways that those neurons can connect with each other is, I have read, is equal to or more than the total number of protons in the universe. Now, I don't know who did the math, but it's a very large number. So you can imagine the brain has the capacity to organize itself in a billion different ways and to respond to things in a billion different ways, depending on just which neurons light up, you know, and which neurons lit up in the past and what his experience was with that pattern. So, consciousness. You know, when they do an MRI, what they're actually looking at, an fMRI, what they're actually looking at is which areas of the brain are using the most oxygen. And they figure that that area that's using the most oxygen is the one that's most active doing whatever they've asked this person to do at the time. They give them a task, you know, think of blue or something, or whatever. And they look at the way that the neurons that activate. Well, a lot of those are all those cross-references I talked about, you know, the connections of one thing to everything else, you know. It's, all those things light up because the brain's trying to figure out what the fuck is this? You know, so that's how it does it. It's just, is there a pattern that matches? So, what you can, I think, is a safe conclusion, is that at least some of those neurons that are active are involved in patterns that you know, form a visual image. That's one thing they could do, but they could just form, you know, some idea or situation or something. I may have to actually edit this There's too many pauses, long thought pauses. It's, you know, as I said, you start out with the assumption of a network, and you ask yourself, how would a network do things? Just all these cells. How would that, a conglomeration, however they're arranged, however they're connected, how would they do anything? How would they see? That's a good one, you know. So, I mean, in thinking about that, what would happen when you see something? What happens when you see something? If it's network activity, right? That constitutes your experience of that thing. Is that those networks that are activated by the information that your brain is getting now. God, you know, it's such a beautiful idea. I hope it's right. Anyway, you know, it's the most interesting set of ideas I've encountered. Is the question of how do networks do anything? And, you know, you start thinking about it. And, you know, it's like, to the best of our knowledge, that's all that's going on up here. Somehow, all these interactions produce everything we experience. That's pretty fucking amazing. A fucking bowl of spaghetti, man. Anyway, okay, I think I've probably stumbled through enough for today, so I hope you got something out of it. Thanks. Bye.